But we can look at where stars are classified on the diagram and tell a lot about them. For example, if a star is an M2 star, M, we're looking red, so it's cool, it's not very hot. And 2 is very big, so like red giants would be an example. If we're looking at a B8 star, B is very hot, blue end, 8 doesn't have, not very bright, but it's hot, so it's a very small star. So just by the positioning of the stars on this HR diagram, we can tell a lot about their brightness and their size and their temperature. One of the stars, called Beetlejuice, that is much, much bigger than our sun. And in fact, if it replaced our sun, it would expand outward to Jupiter. And that is an M-class star, so it's a red, it's cooler star. 2, it's an M2 star, so it would be in this location. We have an HR diagram, which really shows classification of stars according to their brightness and their color, as well as their temperature. So if we look at this, the absolute magnitude, remember that's how bright the stars really are, the true brightness of the stars. And we go from negative to positive. The more negative it is, the actual brighter the star is. So the higher the number, the dimmer the stars are in the magnitude scale. Over here we have luminosity. So the luminosity, remember, is the amount of energy produced or released from the star. And these are in relationship to 1. So 1 is the sun, the luminosity of the sun. This is a logarithmic scale, so as you go up each unit or down each unit, you're multiplying times 10. So right here, these stars would be 10 times as luminous as our sun. So in other words, they're producing 10 times that energy of our sun. They're releasing 10 times the amount of energy as our sun. Down here, x-axis, we have the color scale. This is toward the blue end. So O is violet, B is blue, A light blue, F is white, G yellow, K orange, M red. So this is cooler toward this direction. So red is cooler, blue is hotter. So as we go this way, we're actually getting cooler. Temperature's decreasing. So up here we have this in temperatures degrees Celsius. And we have 30,000 degrees Celsius, 10,000 degrees, 6,000 degrees, 3,000 degrees Celsius. So as we go this way, we're decreasing the temperature. So when we classify stars and put them on the HR diagram, we can tell a lot about the stars. We can tell about their absolute magnitude, we can tell about their luminosity and their temperature, as well as their color. So that is the HR diagram. It's a classification of stars. So stellar classification.